for attending today's Virtual Developer Meetup. This is the third event in a series of 6 meetups. Today's presentation will focus on more advanced cloud-native development on OCI, with functions, API gateway, streaming, and events, including a hands-on lab. Special thanks to our trainers, Rolando and Lucas. For question and answers, please use the Slack functionality, the Zoom functionality, or post them in our Slack channel. Please use the Twitter hashtag Oracle Developer Meetup. Over to you, Rolando.
Thank you, Julian. Okay, so let's get started. Let me just minimize this. Okay, so this is our third session. Good morning, good afternoon, good evening. And I am Rolando Carrasco. I am here with Lucas, and we've been delivering this set of webinars for the last 2 Wednesdays. This is our third Super Wednesday. And we will continue throughout our Katacoda scenarios focused on Oracle Cloud Infrastructure. We will continue from where we left from our last session about OCI API Gateway and functions, and we will continue using those 2 components. And we are going to incorporate more components in this session, and we will start talk about them in a few minutes, all right? So thank you again for joining us, and thank you for attending this Oracle webinar. All right. So let's get started. So as we've been mentioning for the last 2 Wednesdays, our idea is for you to get engaged or get along with the Oracle Cloud Infrastructure, and in specific with a set of services which are focused on cloud native development. So we are following the same steps in these sessions. We first start with a set of slides where we explain what we are going to do, and then we go to the Katacoda scenario and actually execute it. So you can see what are the steps that you are going to follow. And then after an hour or so that we present, then you can start doing your own scenarios, and we will be here to help you, okay? So the idea for you is to hear, to see, and then execute, all right? This is going to be a brief introduction about the services that we are going to cover in this session. Then I am going to do a demonstration of the first scenario. And then Lucas is going to take over and present 2 more scenarios for you, all right? And then again, we will be open for questions, and if you want to stay here and do the scenarios on your own, we can support you. We will be here for some minutes after the presentation, okay? So these are the 3 scenarios that we are going to cover today, okay? We're going to start with functions, object storage, which is something that we have already covered in the previous sessions, and API gateway, but here the difference is that we're going to make them work together, okay? We are going to create functions who are going to write into the object storage. Those functions are going to be exposed through the API gateway. That's our first scenario. Then we are going to introduce a new one, which is the OCI event streaming combined with function and API gateway. And finally, we are going to cover the introduction for the OCI NoSQL database, all right? And everything is going to be there in the Katacoda environment as a hands-on, so you can go from 0 to hero, if you will. But just remember that for these scenarios, at least for the first 2 scenarios that we are going to do today, you need to be prepared for the previous 2 sessions that we have covered. At least you need to have gone through the preparation scenario, because we are going to need some of the things that you prepared there. So anyone who wants to execute the scenarios that we are going to do today, at least the first 2, we need things that we cover in those scenarios, all right? And so just keep in mind that, because we are going to use some of the things that you have already provisioned, all right? So in order to get engaged with these scenarios, there are many options to do it. At least you must have an OCI Cloud trial, okay? So you can go to Oracle Cloud and get a trial, and you can execute the scenarios. If you have your own tenancy, you can do it as well. So you have those 2 options. If you do have an OCI tenancy, but you don't want to mess with it and you want to have an additional one, then you can go to the OCI trial, okay? And then you need to go to the the website of our Katacoda scenarios. And again, you need to go through the preparation of the cloud trial tenancy for real OCI scenarios. That's the first one that you need to do. I am stressing the idea because, again, some of the things that I'm going to do in the first scenario needs to have been provisioned beforehand, all right? If you register to this set of webinars, you probably were whitelisted and you can try the cloud trial as well, but you may have a 500 credits, right? Which is more than the normal amount of credits that Oracle usually has for cloud trial, okay? So hopefully you were whitelisted and you got registered to this webinar so you can have that benefit as well, all right? This is something that we've been covering in the previous webinars. So this is what you are going to get after you get prepared for the rest of the scenarios. You will be provisioning VCN, a public subnet, a private subnet, a set of security lists and policies. You also have been provisioning an API gateway. And for that regard, we needed to provision a dynamic group. And also we provisioned the stream for the purposes of the upcoming scenarios, all right? So you already have this and everything is inside a lab compartment, compartment by the name lab compartment, sorry. So you must be ready to go if you have already provisioned all this. Again, this is in the lab preparation, okay? All right, so this is the set of components, platform services that we are covering throughout this series. One is functions, which is the function as a service offering for Oracle, which is based on open source project by the name FN project. So it is basically a serverless offering where you can deploy functions that you can create through different programming languages such as Go, Node.js, Java, Python. We are also covering the OCI API gateway, which is a lightweight API gateway, which is an offering from Oracle. It was released some months ago, and it is pretty well integrated with functions. So every time you publish a functions throughout Oracle Functions and you would like to expose it as an API, then it is very straightforward on how to do it. And the OCI API gateway is a way to do it. And we learn how to provision and how to use it. We are also using the object storage, which is, as the name it says, it is an object storage service where you can pretty much submit and store any type of content, structured content, unstructured content, sorry, images, files, and any type of content. You can store it in the object storage, and you have a pretty straightforward API to get engaged with it. We also are covering the NoSQL database, which is today. This is the last scenario that we're going to cover today. We are going to learn how to use it and how we can get along with it and how we can create tables, sentences, query information, inject information, update information, okay? We are also covering streaming, which is part of the second scenario that we are going to do today. And actually we are going to integrate it with functions. And this is pretty much what we are going to do today in terms of the elements. And this is pretty much what we've been covering for the last 2 Wednesdays, okay? Remember that this is a set of webinars that are targeted for cloud native development. And some of these components, and mostly of those components are in this serverless fashion, which is pretty good in this idea about a cloud native architecture, all right? So this is the first scenario. We are already here in our first scenario. This is going to be functions plus API gateway plus object storage. There are 2 stories that we are going to cover in the scenario. The first one is we are going to write a function that in Node.js, which is able to write an object into the object storage, okay? So pretty simple. We are going to write some code and we already have it, so you can take a look to it. And that code is going to represent a way from Node.js to insert or create an object into the object storage. Okay, that would be the first step. Then we are going to expose that through the API gateway. So instead of doing the FN invoke that we are continuously doing throughout these scenarios. We are going to expose it through the API gateway so you can consume the function via a REST API, all right? Then we are going to create a second function, which is going to receive a feed, an RSS feed, and that RSS feed is going to actually use our function to write the information of the feed in the object storage. This function is also going to be published in the OCI API gateway, and we are going to be able to consume it via a REST API. So that's pretty much what we're going to cover here. Again, as we've been doing in the past, we have the why and the what for this Katacoda scenario. If you are asking yourself, why are they doing this scenario? Well, this is an integrated scenario. You are going to see how these different elements are working together, functions, the API gateway, and the object storage. We've been continue testing the CLI, so you can continue get along with the CLI, so you can keep up with your knowledge about the OCI CLI. We are going to differentiate how we can call a function via the CLI and the API gateway, so you can see the difference between those two. We are going to show as well the integration between Node.js and the object storage, how a Node.js application is able to consume the object storage API. We are going to take a look to that. And continue with the elements that we have provisioned in the previous scenarios about the API gateway. So that's the why. And the what, well, we are going to automate those tasks through the OCI CLI. We are going to test the functions via the CLI. We are going to test the APIs as well via the CLI and through a REST or a curl command. And we are going to validate that those files that we are going to create are actually stored in the object storage, okay? So I think we are pretty much ready to move to the scenario. So this is the Katacoda website that we have created for our 16 scenarios that we already have. We cover pretty much the first, it is 7, I think, scenarios already. And we are in the 8th scenario now, which is the functions, object storage, and API gateway, okay? So let's get started. Again, we are going to be creating a set of functions, functions who are able to write files into the object storage, and then we are going to expose it through the API gateway, and we will be able to call them through a normal curl command, okay? So let's get started. I'm going to show you something new that Katacoda is offering to us, which I think, or we think that is pretty cool at the same time. So the first step in this scenario is to install the OCI CLI. So that's exactly what we are going to do. And while the CLI is being installed, I'm going to show you that now we have, it should be here, the IDE in Katacoda. I don't know why it says the bad gateway, but you can get visual code here inside the Katacoda environment, which is pretty cool because you can actually write code and execute it within the Katacoda environment instead of doing it through just a normal text file, right? So you can do it through the IDE. Let's see if it works in the upcoming minutes, and let's wait for the CLI to
if you need a text editor, Rolando, you may have to completely restart the scenario.
Yes, I'm going to do everything with VI. In case the IDE does not work, I think I can do it through VI. So I've been experimenting that, so I'm already prepared for that. So, all right, so let's just wait for the CLI to get started. And once it is, as with the other scenarios, we need the config file for our tenant and also the private key, all right? So let's just wait for the CLI to get installed, and then we will be ready to go. Okay. Okay, so it's just, okay, so I think we are good. And we need to configure this, the config file and the private key. All right, so let's do it. So, okay. So the first one is the config. And I already have my config right here. So let me just copy, paste it. Okay, now we need the private key, which is going to be the same as the one that we've been using since the previous Wednesdays. And remember, this is being prepared in the lab preparation scenario. All right, so I think we are ready to go. We need to set the lab ID that we been using in the previous scenarios, and this is relevant because some of the things that we have already provisioned includes that ID. So if you don't remember the ID that you've been using, then just follow me and you will see which are the things that you need to change if that is the case. If you do remember the ID that you've been using in the past, then just use it right here. Remember that last week I was in ID 76, I think. Okay. All right. So now let's see if I can get connection to my tenant, and it does. Remember that we need to use this config and in specific this entry because we are using functions. So I don't know if you take a look when I just pasted, but I have done that. All right. So I have my entry for functions. Okay. And as we've been working with functions, we need to first of all, to validate if we have the CLI for functions for the FN, we need to list the context that we use to deploy our functions, and we need to actually create one because we want to deploy it into our functions. So this is exactly what we're going to do in these steps. So now we created the context, and now we are going to tell the FN that we want to use that context. And in order to connect it to our Oracle functions context, we need to set a set of variables, which is what I'm doing now. And once this set of environment variables are executed, we are going to update the context with the connection to our Oracle functions. All right. So let's just wait for that. All right, so now we are going to update the context, and we are going to again list the context, and this star is pointing to our Oracle functions, all right? And it depends on your region. In my case, it's Ashburn, so I have function.us Ashburn, but in your case, maybe the region where you are located, all right? Now we need the name of the user that we used to connect to our Oracle container image registry, which is the OSPhere. And for that, we need the namespace and the user ID to connect to the repository. So now we are going to do it, but you also need a token to get connected to the registry, all right? If you don't remember your token, you can go here. We have already provided this for you, so you can create the API token, all right? So now let's log in to our repository. With which user? The one that we have here, okay? I'm just going to copy, paste it, and I'm just going to pause my, I'm not going to share what I'm going to do now because I will copy my password and that's sensible. So let me just stop this. I'm going to copy my password, okay? And let me get back here and all right. Okay, so we are back. So this is my user. Okay, no, cannot. This just got freezed. I don't know why. Know what happened, but it just got freeze. Let me see if I can open a new terminal. All right. Now, all right, let me try to relog in again. And unfortunately, I will have to stop sharing again because my password is now gone. But anyways, let me. Okay. Let me just execute this again because I need my user. Sorry, I don't know what happened in the environment. So this is my user. I need to get logged into Docker. So that's it. This is the user. Okay. Now let me stop sharing. I will copy my password and get back to Katacoda. Okay, all right. Okay, so I'm back, paste my password, and login succeeds. So let's continue. And now we are going to create the first function, all right? In order for that, you remember that I mentioned that we are going to create a function who is going to write files or documents or objects into our object storage. So for that purpose, we need a bucket. Okay? My bucket is this one, is OCI Lab 76. I wanted to create it previously to this scenario so I can show you that the bucket it is here and it is completely empty. And you are going to create it with this command. So this is going to create your bucket. So just execute it. And now I'm just going to get the ID of that bucket. Okay. So this is my OSID of the bucket. And then if we, let me see. Okay. So the ID is not working, but I can show you this JavaScript file. Okay. So let me open the actual code of this. So it is a very straightforward JavaScript code. I think the most relevant thing, and we actually wrote it here, is when we sign the request, because every time that you use directly the REST APIs of OCI, you need to sign those requests. But at the end, all the logic that this JavaScript has is just a call to the object storage API to store an object. That's it. But in order to do that, we need to sign the request. And in order to sign the request, we need to get a set of configuration to get connected to OCI. And we need actually our keys in order to sign the request. So in order to do that, we are going to copy our private key into this folder so we can have it. And we need to configure, and this is something that we need to do previously to connect to our object storage, and it is this set of elements, which is the namespace, the region, your user, your fingerprint, and many other things that you need in order to sign the request. So in order to do that, we need to edit a file which is located here, which is this file. Okay, I am just going to show it to you. And here in these lines, we are going to incorporate this information. Okay, so let me get out of here. And in order to get that information, we have this execution, and you can copy and paste it here. Just keep in mind something, that in order to get the fingerprint, you need to go to the OCI API key.pem and copy your fingerprint from there, and then change the value for the key fingerprint and paste it here. Okay, and once you do,
that's actually my mistake, Rolando. It should say the config file. That's where you copy the fingerprint from, not from the PEM file.
Yeah, correct. Yeah, it is from the config file. Yes. So I already have that. So in order just to be clear and not confuse you, I am referring to this thing. Okay, you need to copy this value. Okay, this value needs to be inserted here. All right. So I already have it. So I am just going to copy from my text file here. And once I copy this, then we can edit, which I already have it here. And I'm going to paste it here. Okay. Okay. All right. So it's okay. So I already have the set of information that I need in order to sign the request, okay, among other things. So I already have this in this OCI configuration.js. Now I need to install the libraries through npm. So all the dependencies that I need in order to execute this code, I am installing it right now. So that is done. And I am going to test the JavaScript. Okay, so the Node.js code, I'm going to test it right here, because we can do it directly from the OS. So what happened here, this is creating a file by the name secret.txt with these contents, file content, contents, and more contents, okay? So this is what our file needs to be, or is going to be included, okay? So let me just list the objects that I have in my object storage, and I must have one. And as you remember, I show you this screen, which is my bucket. If I refresh it, then I will see one new object in the bucket, which is the one that I just uploaded from the code. All right. So I can list the values of my bucket, and now I can get the file. Okay, I'm getting the secret.txt, and I can actually list it. And this text, this is the same as this one. Okay, so pretty straightforward. We already have our code running in our operating system, but what I want to do is to create a function that can wrap that up and deploy it into Oracle functions. That's the main objective. Okay. So the contents of our function, it is pretty simple at the same time. It is, let me show it to you. Okay, it is located right here. We actually learned this in our previous session. This is where it is located here. And it is very straightforward. This function is actually just calling the writer that I just showed you. So as you can see, it is basically calling this file writer code that I just showed you. And that's basically what it's all about, okay? So I'm just going to echo the lab ID just to remember that we are using this ID. So we are going to deploy our function in the application that we created in the previous scenario, which was last week. Remember, this is relevant because you already have an application with that name. So let me show it to you because probably this can be confused. So let me just show it to you. So if you go to developer services right here, and go to functions, you must have already an application with that name, okay, in your compartment, which in my case is this one, okay, is lab 76, because we created it last week, okay? So we are going to use that very same application to deploy our functions. So let me just change directory and deploy the application. Remember that to deploy a function, it's just basically, you just get located into the directory where your function is located, and you just do a deploy application and the name of the application. In my case, lab 76. So the function is already deployed. And now I need to configure an environment variable throughout within my function, which is the bucket name, because I'm going to store the object into the very same bucket name. And then I'm going to do the call directly to the function. So remember, this is going to take some seconds because it is the call start for the function, and it takes like 15 seconds to get the call start and then execute the function. Okay. Once that is done, then we will have two files in our bucket. Okay. The one that we uploaded through the command line directly to the JavaScript code, and secondly, the one that we are uploading now through the function call. Okay. So if we do an object list, now we may have two objects. This is the second object, all right? If you want to take a look to it directly into your web console, you can get here, just refresh it, and now you may have two objects, okay? All right, so it is here. And if we want to get the object, we can do it. And finally, we can list it, okay? This is the text that included the file. So we are progressing in our scenario. Everything is working okay. And now we are going to create or expose the function through the API gateway, okay? And again, remember that the IDs are relevant for what we are going to do now, because we are going to get the IDs for our function, okay? And remember that every single resource in OCI has an ID, and in this case, it's this one. we are going to create our deployment JSON file, which is something that we learned in the last session. So let me just create the file, and we need to edit it with this information. I already have it here, so we can save some time. So it is here, and paste it just like that. This is explained right here. So we created the API deployment JSON file, and this is what the file includes. But you need to incorporate the function OSID, all right? The function is OSID is the one that we got in the previous step here, okay? So we are telling the API gateway that we want to call this function, all right? And then we need to tell to the deployment that we want to update it and incorporate this new resource, okay? And again, we need the ID of the deployment that you created last week. In my case, let me just go there. In my case, and probably it is your case because I think can be normal. I am using ID 76 because that's the one that I started to use last week. But when I get prepared my environment, I use ID 1. So if you have this mix of IDs, and I wanted to do it on purpose, so you can see how you can move forward. In my case, I have this deployment with 1 at the end, but we are using ID 76. So when I execute this, okay, some of the things that are here are with my API deployment _ lab ID, but in my case, it's not 76, it's 1. So what I'm going to do it's very simple. I am just going to execute these commands. Okay, but instead of using the $lab ID, I'm just going to include my deployment _ because that's the one that I'm using. Okay, probably that is your scenario. I just wanted to show it to you. And now I am going to update my deployment. All right, so everything is all set. So remember that this is an asynchronous call, so this is going to get executed in the background, and after a few seconds, we will have it ready, and we will be able to execute the function through our API gateway. Okay. Remember that this is just a normal curl, so if we do it, okay. Now we have how many objects? 3, because we do it manually, we do it through the function, and we do it through the API gateway. And again, if you refresh it in your console, you may have 3 files, all right? And we are pretty much at the end of this scenario. We still remain one more thing, which is the RSS feed. And if you want to execute these commands in order to get the file, it is fine. You can do it right here. Okay. And if you want to do it via Postman, you can execute your function directly in Postman, if you will, because it is a normal REST API. So if you want to execute this is the endpoint, and this is the name of the resource, and you can do it. So we will have a 4th file by the name postman.txt, and you should have it here. Okay. So everything is working properly. Everything is straightforward in terms of how we are progressing with the scenario. All right. So this is the last one, and I think this is pretty fast because some of the things are already been explained. So this is the scenario where we are going to expose through the API gateway an endpoint that is going to be receiving an RSS feed. And that RSS feed is going to pass through a function, and that function is going to use what we just been deploying, which is the file writer. So the feed is actually going to be written as an object in your object storage, and that is exactly what we are going to do. That code is here in this repo. The code was written by Lucas, and you can take a look to the code. So you can, if you are curious about how it is done, you can take a look to the code. We need to export this variable. And finally, if you want to take a look to the function, it is again pretty straightforward. It is just encapsulating the code to Node.js application, which is receiving whatever it is in the feed and calling the writer in order to write the object in the storage. Okay, so we are going to deploy the function just as we've been doing in previous steps. And this is going to deploy the function in my application. Remember, the ID of the application is relevant because it is where this function is going to live. And once we do that, we will be ready to go to configure the function because it needs two parameters, the bucket name and the RSS feeder and the endpoint of the writer, sorry. And once you configure those two variables, then you can execute the function. And again, this is going to take some seconds for the cold start, but this is going to receive the feed from this URL. This is the feed URL, and this is going to create a file by the name this another Amis blog.json, and this is going to include the RSS feed. All right, and that's it. This is the feed. So now we will have how many objects? 5, because we already had 4. So this is the 5th, which is another Amis.json. We can get it from the bucket again, sorry. We can list it, and it is a very large JSON file. And the last step is just to publish it through the API gateway. Okay, so we just need to get the IDs of our functions. In this case, the RSS feed function that we just created. We need to create our JSON file that describes the resources that we want to expose through the API gateway. And then we just need to include this information, which contains the IDs of the functions, all right? And pretty much it is explained right here. And now we are going to update our API deployment. Again, this is an asynchronous call. So let's just wait for that to happen. And now it is pretty much ready to be executed from the OCI endpoint, okay? Oh, sorry. What was that? Okay, I think it is still doing it. If you want to inspect your API deployment, you can do it here. You can go to this URL and see what was created at the API gateway site. And now probably must be ready to be executed. Okay, and again, we will get an object list into our object storage, and now we may have 6 different files in our bucket. Okay. And the last object is this one, which is from the API gateway. And that's pretty much what we have in this scenario. It's kind of a large scenario, but you will learn a lot of things. You will continue learning about the OCI CLI, continue learning about how to deploy functions, continue learning about how to publish those through OCI API gateway. And if you take a look to the code, you will learn how to push an object into the object storage from a Node.js application. So I think that's it, Lucas. I hand over to you for the next scenarios.
Thank you very much, Rolando. Trying to start my video. Almost there. Yeah, that's me. Hello, everyone. And now I will share my screen as well. And go to the next step in our session. And we're changing gears. Remember everything Rolando said, but then also open yourself for something new. We're looking at the streaming service, which weirdly enough can be found under analytics in the menu. I'm not sure why it's there. If you hear streaming in the context of OCI, think Apache Kafka, and then you have the right mindset. So it's about events, but there's also an events service that we discussed in our first session. which is something else, that is cloud events. That's the OCI resource related events. Now we're talking about application events or any event really that we want to stream through a topic, asynchronous communication patterns, publish, subscribe. That's the OCI streaming service. Okay, so it's Kafka-like. And if you don't know exactly what Apache Kafka is, that's fine. We don't have time to go into too much detail. Basically, producers or publishers who know nothing about consumers publish messages and then continue with their lives. And consumers can consume messages in their own time without knowing exactly where the message came from. They can process the message. There's a guarantee that messages are delivered in the same order as they were published. And I think that's for now all you really need to know. Events are published and consumed through REST API calls. And there's a Java SDK, which is basically a wrapper around these REST API calls. There is no push to consumers. So the consumer itself needs to go out and fetch another batch of messages, or at least check if there are messages available. There's no automated fetch. Of course, you could hide this away in a client library that does a poll behind the scenes that make it seem like there is a push. There really is no push, not from the streaming service itself. So the message retrieval is done through something that's called a cursor. It's a stateful object that you use to remember what the latest offset was that you already fetched messages from. And then if you ask for the next batch of messages, you will start from that offset, unless you indicate in your cursor that you want to use a different offset. So you can always get the earliest message, or only the latest messages, or the messages from a specific offset or from a specific point in time, which can be converted to an offset. There's no filter that you can apply upon reading messages. So if you want to only consume certain messages, you have to do the filtering in your consumer logic. It's not something that you can have the streaming service do for you. Streaming will retain messages for a maximum of 7 days. I don't think there's an extension to this setting. The maximum throughput that you get is 1 megabyte per second, and the maximum message size is 1 megabyte. For most applications, I think that's more than enough. It's generous. So you can have fairly large volumes of messages. So remember, we discussed events before. The events service is about cloud events. It's about something happened in one of the services you see on the left with a cloud resource. A database was created, an object was deleted, a bucket was moved. All of these resource change events are published as cloud events, and these cloud events can be sent towards either a notification topic, to a function, or to a stream. And that's where the two come together. So the stream can take care of any message, and the events, the cloud events, is one type of message that the stream can take care of. The stream, by the way, doesn't care whether it's a cloud event or any other type of event. So as I said, there's no push to your function. If your function wants to subscribe to a stream, the function should check periodically with the stream whether there are any messages. You could try to implement something like a push in the following way. You create a function that has as its only job to be a message listener on behalf of certain backend functions. So this message listener could check every second, every 5 seconds, every 10 seconds, whatever you like, with a stream to find out if there are specific messages. And then it could dispatch those messages through the API gateway to the intended function. So the functions on the right have the impression that they are pushed from the stream. But in fact, we need this additional component to implement that push feature. We could use, and that's a bit of a trick, a monitoring service health check that's normally used to check the health of endpoints. And those can be scheduled. So you could have a scheduled call to a function using a health check. But now we are digressing. Why are we even talking about streaming? Well, streaming, messaging in general is a very important part of cloud native applications, of serverless applications, of the microservices architecture. So a streaming service is a key component in many application architectures and solution designs. Streaming on OCI is a high volume publish subscribe messaging platform. It makes it very interesting. It's compatible with Apache Kafka and Kafka Connect. So Kafka Connect is a large collection of connectors that can both read messages from a stream and publish those messages to specific endpoints, or read from specific endpoints and publish to a stream. And again, we don't really have the time, but I would like you to take a look at what Kafka Connect can offer you. If you're familiar with Oracle Service Bus or SOA Suite, think adapter, technology adapter, and you know more or less what Kafka Connect is about. Streaming is also important because of its integration with other services, specifically the cloud events that I mentioned and functions. And you can easily get started with streaming through the CLI, as we will do in a moment. In the scenario, you won't have to create a stream because it's already there. It's part of the preparation scenario. You will create a function that listens to a stream, and we will use the OCI console to check what's happening on the stream. And last point really should not be there. So let's take a look, and hopefully my environments are still up. We are in the console, and in the console under analytics, there is streaming. And under streaming, there is a single stream, which was created by the preparation scenario, and there are no recent messages. I can create a recent message. Hello, message, produce, nothing spectacular. I can produce again, and again, again. And then I can check for recent messages. And now I will find my hello message. It has been produced. In the scenario, which is this one, and now I would like to show you the built-in Visual Studio Code. It's here in your browser, if it's running. It took me a while to get it running in this environment as well. So I was having the same problem that Rolando had. After 4 restarts of the scenario, it was available to me. So here we go. A list of streams, and we already know there's a single stream. There it is, the lab stream. And I need the ID of this lab stream. I need it in my environment variable. And here I'm going to create the cursor we were talking about. I was talking about. So it's a cursor that's based on reading from the stream from partition 0. Here is the stream ID. And here is my trim horizon, which basically means I want to get all the messages that are available. So now I have created my stream cursor, and I have a cursor ID. Now, when I try to get messages from the stream, I need to tell the streaming service which cursor I'm using to retrieve messages. So then it'll know and update the cursor object server side from which offset it should return messages, depending on the type that was set, the partition that was specified, and the offset of the previous call. So here I'm asking for all the messages. These are 4 messages. If I try again, I will get 0 messages because I said trim horizon, which basically means get me all the messages every time. If I'd said latest, I would not get the messages I have read before. So I could go to the console and publish an additional message. One more, no, that's not what it says. It's good enough. So now there are 5 messages on the stream. If I ask for all the messages, I get only 1 because there's only 1 recent message. If I ask for the messages down here, I should get 5 because there were 4 and then 1 was added, so now there are 5. You notice that you can't actually read the contents of the messages. The contents is here, it's base64 encoded. You can see these 4 are the same and this one's different. So this is the latest one, it's the one that says 1 nor. And let's see if we can actually read the messages. So I have a node application, and I have to add some configuration information to one of the files in the application. So it's the OCI configuration JS. Here we go. It's the stream sub OCI configuration, and here it should go. There you have it. And of course, I should get the fingerprint that we were just discussing. Config file, fingerprint. Sorry about this. We have tried to make it as easy for you as possible. Some things are still manual. Okay, there's my fingerprint. Now I will navigate to this directory and do an npm install to install the required libraries. And now I'm invoking, there were a lot of messages from earlier today, I now recall. I'm invoking my node application, and basically the node application will read the messages from the stream. Perhaps I should. Here I have also specified trim horizon. Maybe I should specify, well, if I specify latest, I won't get anything. Never mind, let's just leave it at trim horizon. It's important to realize that in this function, we do the translation from the base 64 encoded message to readable message. That's happening here. It took me a while to figure this out, but you can just use it, of course. Let's open the console. Let's produce another test, another message. And let's check down here if the other message is returned. Actually, I don't see it right now. Feels like it's maybe returning them in the reverse order. No, I'm not going to look for the message. That's like a needle in a haystack. I was doing a presentation this morning using the same stream, so my stream is somewhat polluted with many other messages. So let's go and publish some events. So here I have another node application, and of course feel free to check out the code yourself. It's a stream publisher, and you won't be able to immediately recognize exactly what it's doing. But here is the essence. It's making a post call. It's making a post call to the stream's endpoint for a specific stream. And as the body, it's sending the encoded messages. So here I'm publishing a message. I'm publishing a message. It should be down here. Message published to stream. And now if I check, for example, in the console for the latest messages, I will find my message to be published to the stream, which is the message that I published over here. Of course, this is what you would expect, and it doesn't feel really spectacular. And especially with this volume of only a few messages, you won't get excited. But if you have worked with Kafka, if you've worked with queues in general, I'm sure you will recognize the importance of having such mechanisms at your disposal. And I can check more messages. I can publish more messages. That's not extremely important. In the interest of time, I won't demonstrate these steps, but in this final step of this scenario, you will create a function that publishes events to the stream, or messages, probably I should say, to the stream. Just as Rolando did in the previous scenario, we take a working node application and we take it from this Katacoda environment, wrap it as a function, publish it as a serverless function to OCI, and then invoke the function. It's not spectacular, but it's nice to know that you can do it, that you can do it fairly easily. Final topic for today, and that's the NoSQL Database Cloud Service, which is not a very good name because it's very much not SQL free. I will explain. It's a fairly new service. It was launched in February, so only a few months ago. And it's a fully managed cloud service. So you can use it. You don't have to set anything up. You don't have to manage anything. You don't have to take care of backup and recovery. It's all done for you. It's based on the Oracle NoSQL database, which itself is based on the Berkeley DB storage engine. And that's extremely mature and proven. I think it dates back to the 90s. It was acquired by Oracle as part of an acquisition that wasn't targeted at Berkeley DB, but still it was a nice bonus, I guess. And even though it's called the NoSQL database, it's very much not only SQL, because it's also SQL. It's the also SQL database. It does both schemaless JSON as well as SQL-based operations on relational data. It supports asset transactions if you want them. But if you can live with relaxed consistency, you can work more in a base eventual consistency style that will improve the performance and throughput. It supports partial JSON updates, so you can store JSON updates in the database. And if you need to update a piece of the document, you do not have to retrieve the document, change it on your client side, and send the complete updated document to the server, but the updates can be done server side. There's this neat little feature that's called time to live. You can define for records that they should auto expire and when they should auto expire. There's built-in data redundancy. As I said, it's a fully managed cloud service, and it supports, that's a fairly recent addition, a multi-region architecture. You get automatic replication of your data changes across regions. So you have like a global database, something like InfiniSpan or a Cosmos DB, that's also supported by this NoSQL Oracle Database Cloud Service. It has REST APIs. Obviously, it supports the OCI CLI, and there are SDKs in several languages. And as part of the scenario, you will use the SDK in Node. To be honest, I don't really understand how the cost is calculated. We're talking about read units and write units. Storage, I understand, and that's okay. And that's fairly cheap. That's extremely cheap, by the way. But how exactly the read and write pan out, I'm not sure. So I'm going to skip this slide and discuss the scenario. So why are we introducing the fully managed NoSQL Database Cloud Service? And persistence, of course, is part of almost any application, whether it's cloud native or not. In this case, it's certainly part of cloud native applications. There's also the autonomous database, of course. But in many cases, I guess that the NoSQL database provides a simpler and a cheaper persistent solution. It's interesting because it's global, it's multi-model, it's both schemaless JSON and relational. It can do asset and it can do base. And we will introduce the Oracle Cloud Infrastructure CLI for making a flying start with this database service. We will create tables. We will insert and query relational records, insert and query JSON documents, see how this partial update for JSON the documents works, and we'll briefly use the Node SDK to also query and manipulate data. So that's basically the scenario. Now, I started this scenario quite some time ago, and this environment probably is now invalid because it is available only for 1 hour. Better use this one, which is slightly later, although I have not yet logged in to Docker. Oh, Docker's not here. That means I can't create a function. Never mind, we'll just skip doing the function. You will do that yourself.
It takes like 20 seconds to get installed. Lucas, if you want to do it,
I shouldn't need it.
But I mean, just if you want it or need it.
No, I don't. So let's first take a brief look at the console. Here you will find the NoSQL database service that wasn't there all too long ago. And at the moment, there are no tables. No tables up my sleeve. But here we're going to create a table. In this single OCI CLI statement, I'm creating a table, and it's, well, let's look over here what it's called. Refresh the page, and I guess there will be a table. Et voila. There is our table. And it has a horrible name, lab table 1. It has 3 columns, 1 primary key. Well, you can see the table definition. Of course, there are no table rows. And how do we find out if there are table rows? By executing this SQL statement. So here we go, NoSQL database, very much a SQL statement. I can also check, of course, on this side if the table has been created, and yes, there it is. So again, from the OCI CLI, I can create records. I can query, well, there's nothing, so I will skip this one. I will now insert a record, and it will happily insert 1 new row. I can query it again, and of course, this time I will find this 1 row. It looks like a JSON response. It is a JSON response, but at the same time, it's relational data. And I can find that same record on this side. There we go, adding a few more records. Querying all these records. And of course, I get all the records. I can, of course, find all those records on this side as well. There they are. Nothing spectacular, but still nice to know that it works. So I'm going to create an additional table, and in this table, I'm going to store JSON documents to show you, well, that it's also supported and that it works in a very similar way. Checking over here for all my tables, there's the lab documents table, and it consists of 2 columns, an integer primary key, and a column of type JSON. This is where the JSON documents will go. Surprise, surprise. So now inserting a document into this table with almost the same data that before we had in the relational table. And if I check the table rows, run the query, I will find that I've got a single record with which has this document. And in this document, there are 4 people, or the details for 4 different persons. Now I'm going to also insert a completely different document. This is a document with a list of all the countries in the world. And both documents are now in the table, and they are completely unrelated. Well, they are both in this table, but it's schemaless, so there's nothing enforced. And now it's my responsibility as a developer to ensure that I'm not doing the wrong things on the wrong records. This is one of the essence of NoSQL. You don't have to define anything upfront, but then you have to be very disciplined later on, as opposed, of course, to a relational database where you do very careful database design upfront and can be less diligent afterwards. Let's not get into that debate, even though I realize I started it. I'm going to query against this table, and I'm going to provide a where clause where I state I want this staff element to exist in the document, and only if it does should this record be returned. Well, the countries document does not have a staff element, but the document with the people in it does, so that's the one that's returned. I will skip this one. Here I'm asking for all the countries from the JSON document, all the countries where their country code or their country name alphabetically comes after Switzerland. So you can perform a query with a filter condition on the contents of the document. So there's only one record from which this data is returned, the record with primary key value 5. And from this document, I only get the elements that fulfill this condition. So here I show you the partial update. So I'm updating the document table. I'm updating the record for primary key 5, and I am changing inside the document the value associated with the key NL to Holland. Actually, it should be the other way around. It's currently the Netherlands, and now we're changing it to Holland. But anywhere you say Holland, it should really be the Netherlands. Holland is not a name we should use, but that's a different story. So I'm performing this update, and I get the complete document returned. And here we go. NL now is Holland, and before it was Netherlands. And that is something that you just have to believe from me. In the staff document, I'm also doing a partial update. I'm adding an additional person, and this additional person is Dan. And when I ask for this document, I will see that in addition to the 4 people that already were there now also is Dan. So partial update. In the final step, I'm going to make use of my of the Node SDK for the NoSQL database. And I'm going to execute this code. Now I'm going to not discuss the code in a lot of detail, and I should of course add some configuration information. There we go again. So I'm going to copy these lines and paste them very conveniently into the editor. And oh shoot, of course, the fingerprint. We have to find a better way of doing this, Rolando, even though it's way more convenient than it used to be. Okay.
Yeah, I have an idea.
Yeah, I know. And now I'm going to execute this code. And what it will do is it will retrieve data from the first table that we were discussing. So if you take a close look at the code, it performs a number of queries. First of all, from the table, it gets the record with primary key 1. That's the first result that we have over here. Sorry, this is the first result that we get over here. Then the second query, select star from table name where name equals Rolando. So that's very relational, very SQL. Here we select simply all records and print them out to the outline. And finally, we add someone, we add Jürgen. And of course, if I now run the code again, then Jürgen is not added again, but in this result, Jürgen is shown in addition to the other records we already had. So the final step here is to create a function, deploy the function, and invoke the function. I'm not going to do that. It's something that you can perfectly well do on your own. So hopefully this gave you an idea of what the NoSQL Database Service is about, and it's very much about SQL, even though it's called NoSQL. But you can also do the kinds of things that NoSQL is touted for. So this brings us to the end of what we are telling you and showing you. And this is where it's time for you to try it out for yourself. So the exact same scenarios that we've demonstrated are available for your own use. You hopefully already have your cloud trial environment. You hopefully already have done your preparation lab. And you should now be able to, well, to go through the scenarios we discussed today to take a closer look at the services that we've introduced. Rolando and myself will stay around for well, at least half an hour or for as long as there are questions. So if you need help or want to ask questions, please use the Q&A window and we will try to help you.
And just remember to have by hand your IDs, because these scenarios in a specific use what you have been using in the past in terms of the Katacoda scenarios. And for example, the API deployment ID, you're going to constantly using it. So you better get, you better have it. And in case you have a different ID, then as I just showed to you, you can fix it pretty straightforward. And I think that's it, Lucas.
Yeah. So thanks for your attention. We would appreciate it if in the Q&A window you can express something about your feelings on this session. Or was it useful? Do you have suggestions for us to change anything in the way we present or implement the scenarios? Please help us help you. We're glad you were here, and we hope to see you next week. And what are we going to do next week, Rolando? It's
absolutely,
Kubernetes, isn't it?
Yes, Kubernetes is the next topic, and we are going to create from scratch a cluster. Then we will deploy a set of services and use them and scale them. And I mean, if you like the topic, if you are kind of new into this, or you are kind of new in having Kubernetes on top of Oracle Cloud Infrastructure, I think it's going to be a good session for you.
Yep.
I am reading some of the comments in the chat, and some of you are saying that it's okay to have manual steps as well, instead of just copy pasting, which is true. Yes, what we've been trying to do is to keep you or to have the scenario as much ready as possible, error free, if you will. So
foolproof if you want.
But to be honest, and this is also something that is good to share with the audience, is if you are looking to create your own Katacoda scenarios, it is quite a challenge, to be honest, because every time that you execute it, something else happens or something different happens because of the environment or because of whatever. So it is, or I think has the same opinion, but it is pretty fun to do it, but at the same time, it's pretty challenging to do it and have it error free. So Holger was saying that probably manual steps will also help to keep focus, and you are correct. And probably we can incorporate some manual steps in the future. And also, they are asking if they can have the presentation. Yes, Lucas published it in a slide share, actually.
Yeah, I will make the slides available again, and I will provide the URL to it in the chat for today, and also next week we'll provide the link for the chat of last week. I've also provided in the chat window the URL for the Red Expert Alliance YouTube channel, where there are the recordings of the first two sessions, and there will be the recording of this session as well. Thinking of which, I'm going to stop the recording right now. So do you have any parting words, Orlando?
No, I think we are fine. Thank you again for joining us, and hopefully you can get back next week and join us to cover Kubernetes. And we are halfway for this three Super Wednesday already. And again, if you want to give us feedback, there is a Slack channel, also via Twitter, where we constantly publish this, because we do need it. We would like to hear from your end, what are your experiences following the scenarios, even if it is a bad experience because you cannot continue or you couldn't finish it. That is fine for us.
Please let us know.
Yes, please let us know, because then we can realize it and fix it. So if you had a very bad time just to follow any of the scenarios, let us know. And believe me that we've been constantly updating that Git repository with changes. And but anyway, it is always the possibility to have an error.
I think we should also thank Mark Lamerix for the feedback he has been providing. He has been very diligent in pointing out a number of problems with our scenarios and possible fixes. So you will all benefit. We benefit, you all benefit. With that, I'm really going to stop the recording. So we can